Hello, my name is Yegorova Daria. I'm the student of the 10th grade of the Specialized Education and Science Center of the Ural Federal University, Ekaterinburg City. I'd like to present my project Effect of the Bubbles on the Heat Transfer in Heat Pipes. In my research, I wanted to establish how the boiling process affects the efficiency of a heat pipe. My work is relevant as the field of heat pipes is vast and requires careful consideration. Principle of operation of heat pipes. The heat is transferred due to the evaporation and condensation of liquid. I have assembled a transparent heat pipe with a wire heater in order to investigate the phenomenon of the heat transfer. Part of the heat goes to heat the tube and the water in tube. Part of heat inevitably goes to heat the environment, according to the laws of thermodynamics. The center of the wire becomes the center of vaporization for the water in our tube. The formation of small bubbles occurs. They later combine into one large bubble. As the heating continues, the pressure of water vapor inside the bubble increases. The large bubble begins to increase in volume. Buoyancy force increases. Once the large bubble reaches the walls, bubble begins to expand up and down, but water is uncompressible. The bottom of the bubble squeezes the water down in vessel. After expanding, the bubble begins to float upward. Then the bubble comes in contact with the glass of the tube, which has a lower temperature. The saturated vapor molecules begin to condense. The pressure inside the bubble drops and the bubble collapses. The process repeats cyclically. In bubble boiling, steam bubbles arise in separate places on the heating surface, the center of steam formation. Newton's second law helps to explain what happens to a bubble. This is what my experimental setup looked like. In the video you can see the movement of steam bubbles inside the glass tube. In this task, we observe the process of bubble boiling, but we should not forget that the heating doesn't take place only in one spot of the glass tube, and therefore the temperature of the liquid will differ depending on the distance to the place of heating, to the wire. In order to measure the temperature gradient, I used MF58 NTC 10 kΩ thermistors, 8 pieces, ESP 8266 microcontroller and drivers. The thermistors were attached to the tube using Kapton tape. I have written a program in Arduino IDE to read the thermistors. This is how the experimental setup with thermistors positioned along the entire length of the tube appear. The readings from those thermistors were transmitted to a microcontroller and went to my computer. Kapton tape was used for thermal insulation in this instance. All the heat the system receives goes to change its internal energy and to do work on external bodies. In reality, some of the energy inevitably goes to heating the environment. Proper thermal insulation is needed to get efficient operation. However, for the obtained efficiency of installation is 30.34%, which is not much worse than the efficiency of industrial heat pipes.